Okay, class, now I'm going to do the activity for distributions in our outline. And it gave us data on dice, coins, and height. And what I did is I made a Google Sheet where I logged this data. And I got a bunch of pennies and found the age of the pennies. And I typed all that down, 25 of them. Then I got a log off the internet of height in inches of American citizens, and then I got 100 dice rolls, and I did them over here, 100 dice rolls, because that's the data they ask for in this problem. So you're going to use this. I'm going to link it to the class, and you can use it to do all these and get practice making the histograms and such. So first, let's look at this first problem. To roll a die 100 times and record each roll in the chart below. I got 1 17 times. I got a 2 18 times. I got a 3 15 times. I got a 4 15 times. And I got a 5 19 times and a 6 16 times. So the next thing I'm going to do is I am going to take that data and put it into Staplet to make a histogram to take a look at what kind of distribution it is. See, they're asking what kind of distribution it is. Let's take a look at it. It's good to have a picture and see what it looks like. So I'm going to copy all these dice rolls, all 100 of them. Copy. And then I'm going to go to Staplet, and I'm going to use quantitative variable, single group. And I'm going to call this dice rolls. And I'm just going to paste it in. The spacing is fine. All you got to do is paste it in from the spreadsheet and it'll work. All right. And I'm going to make a histogram like we're going to be usually using in here. And here's my histogram and what it looks like. And you'll notice is they're all about the same distribution because you got the same chance of rolling each one. And when a graph of a histogram looks like this, where it's almost flat, that is called a uniform distribution. So this is uniform distribution. And what would be good to do is to draw a little picture of the graph to get a feel for what a uniform distribution looks like. So I'm going to copy that. And they don't really give you much room on this sheet to do it. So just may draw a little bitty picture of your graph. And just go ahead and do that. Oops. Let me maximize this one. And so you can get just a little bitty picture like that. Let's go back up. And kind of put it on the side there. And see, that is a uniform distribution. And so the next one I'm going to look at are the coins. And the coins, they said, calculate the age by subtracting the date, and I did that with a bunch of coins. And these are the ages that I got. So I'm going to take and copy all these ages. So I'm going to copy all the penny ages and take those into Staplet. So like start over on Staplet, go back and go to data analysis and do a single group. And this is penny age. And paste it over and begin analysis. Let's take a look at that one. Let's make it a histogram. And you'll notice what this histogram does and what it tells us is most of the data is pretty recent, within 5 years, right? Less than 5 years, 17 of them are. And then from 5 to 10 is 5 of them, and then 10 to 15 is 2, and then there's only one coin that was over 15 years old. So let's go ahead and copy this over. Frequency versus penny age. And paste it. And when you're looking at frequency versus penny age, what does this graph look like? Well, since most of the data is up at the front, and then it dips down like this, like it slopes down to the right, this is called a right skew. When most of your data is on the left and it skews downward to the right, think of skew as like skiing down, skew. And so this is a right skew. distribution. And if the data were all bigger on the end and it was going down that way, it would be a left skew, like skewing down like this right here would be a left skew. But this is a right skew where all the data is at the front and it's skewing down to the right. That is a right skew. Next thing I'm going to look at is the heights and the classes. What kind of graph would that give us? So I got all this data with the height on it. And if you need to pause in between this, do it. So I'm going to go over back to my data. And here's all my heights in inches. What I take, about 26 of them, it looks like. And I'm going to use Staplet again on these heights. Normally we would do these in class. We would have done all 3 of them in class, but of course we're not in class this year, so I'm going to dot plot. I'm going to do a histogram with it. And let's make the histogram with a little less width on each one to give us a better feel for how the data is going. Let's do that one, 4, yeah. With an interval width 4. And what you'll see is most people are kind of in the middle, right? And there's people to each side as well, but most people kind of group up in the middle. And so I am going to take that data right there and copy it and paste it over to my graph, or you can just draw a little picture of it. And you'll notice on this one, it kind of does like this, like a bell shape, like that. And this is an example of a symmetrical distribution, or normal. Though you'll see it called normal a lot. This is like a normal distribution. We'll get to normal distributions later. So this is a symmetrical distribution. And what it means is it almost mirrors itself. See how close that is to being a mirror starting in the middle? And it's symmetrical on both sides for the most part. It's not going to be completely symmetrical, not with this little data, but it's going to have that look to it, and that is symmetrical or normal distribution. All right, that is our distribution problem for the outline.